Today's lesson is food algebra. Yummy. Today we're going to be focusing on writing algebraic equations. An equation always has an equal sign. Equation equals. And you are going to be solving for an unknown variable. So we're focusing on translating these words into equations and solving for that variable. So here's our first problem that we can work on. Trey has 5 7/10 oranges. He ate some of them. Now he has 2 1/10 oranges left to eat another day. How many oranges did Trey already eat? What I'd like you to do, and I know this is going to take a while, is hit pause and copy this word problem down, word for word, sentence by sentence, because we're going to do something and look at some keywords to help you translate this into an algebraic equation. So get ready to copy down this story problem, word for word, sentence for sentence. Hit pause now and then play when you're ready. All right, let's look at some of the keywords that we need. Sometimes when we see a word problem, it can get kind of overwhelming. So it helps to underline or highlight or underline with a color the keywords that we need. Like 5 7/10. We know he started with that many oranges. He ate some of them. That means we don't know what amount, but he ate some. And now he has 2 1/10 left. So what we want to know is how many Trey already ate. Go ahead and do that same underlining that I just did if you haven't already. The already eaten oranges are right here, the sum, and we showed that with a question mark. We could also give it a variable. Now, I know that orange starts with O, but if we use an O as a variable, it's going to look like what digit? A 0. So that's probably not a smart move. We could do N, though, when we do our equation. N for a number. We don't know how much. So let's put this into an equation. Equations read from left to right just like a sentence in a book. So at the left of the equation will be the starting point, and then at the right will be the ending point. So this would look like this equation. 5 7/10 minus some number equals 2 1/10. What we're basically saying here is from left to right, Trey started with 5 7/10 oranges. He took out a number, we don't know how many, and the reason why he took them out is, well, because he ate them, so they're gone. We have to take it away from the set that he started with. And now he has 2 1/10 left. If we were to draw this as a bar model, it would look like this. I switched some colors there. Okay, Trey started with 5 7/10. We know that he ate a certain number, but we don't know how many. So that number is part of the original. It makes up part of it. And the other part is the 2 1/10 that Trey has left over. So it's 5 7/10 is what we started with. We took away a certain number and we're left with 2 1/10. Now, if we actually had some oranges, we could actually physically take them away to show it. But the bar model shows it as well. It also shows that 5 take away n equals 2 1/10 would be the same as 5 7/10 take away 2 1/10 would give us n. So that's how we could solve this equation. If we were to write an inverse equation, it would look like this. 2 and 1/10 plus n equals 5 and 7/10. This whole thing. And its inverse, we remember this from yesterday's lesson, because adding undoes subtracting. So you could think of it as a counting up problem. Starting at 2 and 1/10, how can I count up to get to 5 and 7/10? So you could do that with some arrow language, and it might look like this. Starting with 2 and 1/10, it's not a very friendly number, but if I add 9/10, it will be, because the 9/10 will combine with the 1/10 to make another whole. So that will get me 3. And I could add 2 whole more oranges back, and I could get up to 5. And then I could add the 7/10 and get up to 5 and 7/10, which is where I want it to be. And now I can look at how many hops I made. It's kind of like a number line, but arrow language is another way of doing it. So I've got 2 as my whole number. That might be a nice place to start. And then, yikes, 9/10 plus 7/10. Okay, do some side work over here. 9/10 size pieces plus 7/10 size pieces would make 16/10 size pieces. But that's an improper fraction. I can't write 2 and 16/10. That's just funky. Although technically it is the correct amount, a math pro would never write it that way. A math pro would take this 16/10 and say, well, I could pull one whole group of 10 out of the 16 and have 6 left over. So that means that I have one more whole number to add to the 2 that I already have, and then 6/10. So the 2 and the 1 would get me 3, and then 6/10, ooh, I can simplify that. They're both even, so I could cut the numerator in half and the denominator in half, make the number of pieces fewer, but also make the pieces larger. So that would be 3/5. 3 and 6/10, or 3 and 3/5 oranges. Don't forget that label for your final answer. So that's one way of solving it, is by counting up to reach that full bar that you started with in the model of 5 and 7/10. Depending on the problem and your brain and the way it works, it might make more sense for you to solve it instead of counting up from 2 and 1/10 and adding a little bit more until you fill the bar. It might make sense instead to do a subtraction problem. Either way, you should still get the answer for n. So our subtraction problem would be written like this. 5 and 7/10 minus 2 and 1/10 equals some number. So if Trey had started with 5 and 7/10 oranges, and let's pretend that we reverse it and do the inverse here, he ate 2 and 1/10, how many would be left? Or started with 5 and 7/10, ate a certain amount, and has 2 and 1/10 left. Either way we think about it, we're going to get the right answer. So we could set up our subtraction problem. And I like to model different strategies. So this time I'm going to model doing subtraction with a tree diagram. So 5 minus 2 would be 3. 7/10 minus 1/10 would be 6/10. So now I have 3 and 6/10, and we know from working the problem already that 6/10 can be simplified to 3/5. So then we would put the 3 and the 6/10 together, and we would get our same exact final answer, 3 and 3/5 oranges. That means that right here, That's 3 3/5. That is the number that we could put together with the 2 1/10 to get our 5 7/10 oranges. What I really want you guys to get out of this lesson today is the whole idea of making an algebraic equation that reads from left to right, just like a sentence. Trey started with 5 7/10 oranges. He ate some or took some away and now has 2 1/10. Remember what we learned yesterday about this equation, this equals sign, meaning the same as? You don't have to write this down in your notes. That means that if this was on a scale, it would balance out because the number of oranges that Trey started with, take away the ones he ate, is the same as, equals 2 1/10 oranges. We might rework this equation and write it in a different order in order to solve it, but the equation that represents this story problem is from left to right, right here. So even though we might rewrite the equation like this, or like this, it's really important to understand that our original equation that represents the story problem about Trey and his beloved oranges is right here. From left to right, start to finish. The start of the situation to the end of the situation. It's okay to rewrite it in these ways to solve it, to get our answer, but we have to understand that this is the equation for the story problem. That's it for your lesson today. Your task is as follows. First of all, you need to figure out the alphabetical order of the first names of the people in your discussion group. So for example, if a discussion group had the following names, actually, here, take a look at your discussion groups and which problem number I want you to solve. I'm going to write the problem number next to your name. That'll go a lot quicker. Here you go. Okay, now back to my original plan. I keep changing my mind. I want to be able to use this year to year. Figure out a list of all the people that are in your discussion group. Put those people's first names in alphabetical order. The first person in the group would be number 1. The second name that comes in alphabetical order would solve number 2. The third person would solve number 3, the fourth person, and so on and so on and so on. Okay, here are the word problems. You are going to be working on these problems and sharing them with your group. Now, you have to realize no one else in your group is going to be working this problem. You are going to explain it to your group tomorrow. Don't let them down. For each of the following tasks, you need to write the equation that represents the problem, and you get to pick what letter to use for the variable. Write the equation for the problem, draw the model, and be able to solve it tomorrow with your group. There might be a couple different ways to solve it, so you decide how to solve it. So, write the equation, draw the bar model, and be able to explain to your group how to solve the problem tomorrow. Enjoy! Task 1. Press pause now. Task 2. Press pause now. Task 3. Press pause now. Task number 4. Hint, this one's a challenge. Your bar model might look kind of different. Press pause now. Task 5. Press pause now. Task 6. Press pause now. Remember, only do your alphabetical number task, not all 6 of them. And be sure to write the algebraic equation, draw the bar model, and be able to explain to your group tomorrow how to solve this problem. Good luck!
Made with Doodlecast Pro.